All right, welcome to Good Choices. So, I'm going to make a choice this morning and spend a lot of time on my LPIC. As I mentioned in the last video, I have the ability to spend basically a full work day on this LPIC, Monday through Friday. So, I would like to do that. I think that would be the best choice. I'm going to keep this intro period here brief, but I just want to say that it's always as I mentioned in a prior video, it feels like a gamble nowadays to choose a cert and work towards it and get it done. So it feels like now more than ever, you really need to think about what you're studying. And I put that time in. I thought about it a lot, and I think the LPIC does make the most sense. It directly qualifies you for Linux admin jobs, which I think are a lot of the times remote jobs. My biggest thing in my career in life is working location independent. It'll give me the flexibility to really become my best self, especially to kind of have my location be more dependent on things like uh, opportunities to uh, realize see my hobbies all the way through, and like because I'm just kind of like not to brag or whatever, but I'm kind of like a polymath. So like, you know, if I can be location independent, I can realize some of my other interests to a higher level. So that's one reason. Also, I just think I can work better. I think the future of work is remote. I think a lot of this intellectual, math-based work is, you need a good work environment for that. You need things to be quiet. You need to be able to take care of like your body if you need something. So um, it's yeah, to be stressed out all the time and stuff. It's just not a good way to work in my opinion. So I'm trying to revamp my skill set and make sure that I'm uh, as valuable and as I can be to organizations and situations uh, that share those same kinds of philosophies and thinking as I do. So I think the LPIC is a good choice for that. Last video we finished all the guided exercises, but we had to stop the explorational exercises a bit short. I ran out of GPT to use for that, GPT-4. So let's go into GPT-4. So one thing I would like to do is, OpenAI, ChatGPT, this is just one of the many, many AIs out there right now. We've also got the one that I even have bookmarked in here. I liked so much, UAI chat. So this is another one, but there's a new one I learned about recently, hugging chat. So what happened yesterday, not being able to finish the video because I ran out of GPT-4. I think that's kind of inexcusable. That's just one of these. It's just another excuse to not make a good choice and do the things I need to do. So if I run into that situation again, I just want to try using these others and even GPT-3, a personalized tutor guiding me through questions. Yes, is going to be the most optimal way, but the least optimal way is to just not do anything. So I want to make a good choice and keep studying for this, even if I don't have the luxury and privilege of studying in the absolute most optimal way. All right, so let's go through these explorational exercises, read the summary, and then close this out this whole section, and then move on to another video. So the first explorational exercise: in a sysv based system, suppose the default run level defined in /etc init tab is 3, but the system always starts in run level 1. What is the probable cause for that? So what we saw last time, just to review, not go over through it in depth again, is that the kernel parameters can specify a run level, and if that's the case, they may override the default run levels set in the service manager. The kernel parameters could possibly take precedence over that and change the run level that the system actually boots out to, regardless of what was in the service manager. So here's the answer. The parameters 1 or s may be present in the kernel's parameter list, which might overwrite the service manager settings. All right, so hopefully that's a satisfying answer. For me, it leaves a little bit to be desired. We went over that a bit in Chat GPT-4. I forget exactly where it was, but let's move on to the next one. Although the /sbin/ although the file /sbin/init can be found in systemd based systems, it is only a symbolic link to another executable file. In such systems, what is the file pointed by /sbin/init? Okay, so we're trying to figure out. So this is just a symbolic link. So a symbolic link is kind of like if you were to like click. So like this right here, this is like the equivalent of a symbolic link because it has this icon here, which is kind of it notifies you that's just a shortcut. So like we can take this image here and we can create a shortcut. I'm not sure. Oh, here we go. Okay, well, I'm not sure how to do that, but basically, long story short, a symbolic link is like a shortcut in Windows. So what what is this so although this file can be found in systemd based systems, it is only a symbolic link to another executable file. So in such systems, what is the file pointed there? Okay, so so I think it would be, it's not going to be this because that's for a sysv based system, but I think it would be the equivalent of this. So let's go back through um the writing and read the section about systemd again. So this is the mount point. So the mount point is, so a mount unit is a mount point definition in the file system, similar to an entry here. So this could be a that might be something I'd consider. There's also the, oh, so they're talking about the symbolic link right here. Yeah, so it does not use that file. So symbolic is mentioned 6 times here. Now this is part of the sysv explanation. So this could be another answer, etc init-d. These are where the actual scripts are run. So I think this is the correct answer because this file, let's see here. So this init is kind of like the equivalent of this in some ways. This, as we saw in the sysv, fundamentally what it does is it lists all of the actions that your system will take upon boot up. So the equivalent thing with systd that lists all the actions your system will take upon boot up um, would be um, as far as I remember, it would be the file that we just looked at. I cannot remember exactly what it was. It's the .d, something .d, rc.d, if I remember correctly. Um, Unfortunately, I'm having trouble finding it now. Okay, so I remember it was next to this symbolic. Ah, here it is. So it's a init.d, and this is an oh, so this is sys. So that's not correct. Here's the next instance. Okay, so that's definitely not the right answer because that was for sysv. So I think this might be the answer here. Uh, etc systemd system / default.target. There it is. Yep, that's the correct answer, and we know that it's because let's see here. Let's go back to the question here. All right, so although the file /sbin /init can be found in systemd based systems, it is only a symbolic link to another executable file. In such systems, what is the file pointed by /sbin /init? The main system binary, systemd binary. So yeah, that makes sense because this is kind of the main system binary for initv, because during system initialization, the init program identifies the requested run level for initv. So you've got kind of this holdover from the older initv, and the program responsible for managing run levels and associated resources daemons is sbin init. So sbin init is the legacy folder used to hold the program responsible for managing run levels and associated daemons and resources. It's legacy for this sysv. It belongs to this sysv service manager, sysv standard of a service manager. So we've got this old school service manager here where everything was contained within this folder. So on the newer ones, we still have that folder for whatever reason. Uh, that folder is referenced for the, so it's like backwards compatible, I think is a way you can think of it. It's got a symlink based on that folder, so it's like if a system's like, oh, I think I'm using sys v still, and it looks in the sysv directory, it's backwards compatible by having that symlink there, and it will direct the user to the correct destination, which is, of course, it's not that hard to remember because we know that the systemctl command is the command responsible for everything. It's the command used to interact with the systemd service manager. So the directory is named systemd. I can't remember exactly what it was. Let's go back and look. So it's lib systemd, and I think we saw that up there. Nope. So the configuration files with every unit can be found in this directory. So I think there's a typo in the documentation actually. Nope, because no, okay, no. This is the system binary. This is the actual compiled code of the service manager. But this is the directory where the configuration files that compiled code uses are stored. So let's take a look at that on my home lab. Okay, so we're gonna do a ls on let's do this. Let's do change directory to sbin init. Okay, so sbin.init is not a directory. Let's do a ls dash. Let's do an ll. Yeah, ll is a macro for ls-l, so that's just a lot easier. So we'll do an ll on sbin. And now we can see symlinks, which is kind of like shortcuts in Windows in a way. It's I think a decent way to think of them. It's not exactly the same, of course. It's two completely different systems, but I think it's useful to think of it that way. Which, you know, of course, you might have to unlearn that to really get a true understanding at some point. But for now, I don't think it's a problem. So we've got a init is what we're looking for. Here it is. And there's the directory that is. Now, this is not the directory. This is the binary. So we can see the binary. Yep, systemd. If we go into that directory, change directory, take a look on files and folders in there. Now we've got all our different systemd binaries, and we have this system folder that we saw before that has all of the configuration files. So we should see a bunch of .conf files here. All right, I don't see any .conf files. Let me just be sure that I'm not just missing them. Okay, so I do see some -config files there, but it looks like So it looks like the configuration file is associated with every unit. Um, the naming structure of them are, because we do have this. So these are units. We see that the syntax of these are units. So we have the system update.target. Let's take a look at the contents of that file. Um, okay, so we're not in the correct present working directory. Let's change into it and then take a look at the contents of this file. So this is a part of systemd. Yeah, this looks like a configuration file to me. Let's go back and look at the folder that has all of the units. So if we do a here, then by way of um um okay, it's libsystemd is the one we want. So we should have a corresponding unit here to what we looked at last time, which was system update.target. Or not. Okay, I guess it doesn't work the way I thought it would. So I think I can clarify my understanding using ChatGPT. Um, but I'm just not sure if it's worth the struggle here. Let me ask a clarifying question. I think that will go a long way. So we're going to say in the libsystemd folder, how are the files relevant, related to the files in the um, folder /system folder. Now, my understanding was that the files in the /system directory were configuration files associated with every unit. And I believe that is the case. We saw that, but I'm not sure. I guess where the confusion lies is what the files are in here, because I thought these would be the compiled files to run the system unit, but like the system units aren't their own programs. They're variables fed to the systemctl program. So I think that actually makes more sense now. If we try to run a unit, we need to do that with systemctl, and we need to do we can do verify, I believe. Let me check that quick. So we've got systemctl options command. So I want to know the commands. Should see things like start, stop, restart. I don't see that. I don't see those commands in here. Okay. Okay, I see some that look familiar. I see enable and disable. I see is active. That's a familiar one. Okay, here we go. Here's start, reload. That's what I was looking for. So I want to look for just a basic verify status, something like that. So like show would be a good one. So these are system commands. Unit file commands. Those are the commands I want when I run this on a unit file. Actually, no. The class of commands I want are in the same class as these commands here. So these are unit commands. They're not unit file commands. Unit file commands would be like editing the file. I want the commands that execute the intentions of the files. That's not relate to the files themselves, but the intentions of the files, the reasons the files are on the system. So, for example, it'd be like starting a unit, stopping a unit, reloading a unit, as opposed to editing the file associated with those things. So here it is. Status. I believe status is a good command for this. So let's do system ctl status, and now we need to feed it in a unit. So I did tab, which shows all the things I can put in there. So let's pick one out. Verify the status. I'd like to verify the status of some of the disks. So like, yeah, so we've got now, since this is my home lab, this is where I'm kind of confused, because from what I understand, I should have 3 disks in there that are live and functional. Looks like I only have 1 disk, this SDA, and then I have 3 partitions on the disk. So that's kind of surprising. I thought I had 3 disks in there working, but it looks like I can only verify the status of that 1 disk. So let's do that. Let's verify the status of the 1 disk I have in there. Okay, and it is loaded, plugged in. Everything looks good. Let's try verifying the status of a theoretical disk B. And yeah, we don't have a disk B on the system, which is surprising to me, because I'm pretty sure maybe it's because this virtual machine is virtualized only on one of the 3 disks I have on my system. That could be possible. All right, but I'm pretty satisfied with the answer. Really a much simpler question than I made it out to be. I do want to run this inquiry quick to try to clear up my confusion, but I think I cleared it up. But let's just do that to see if the AI can really hit home a solid understanding of all of this.
The lib system directory is the main location where system stores its service configuration files and scripts on most Linux distributions. The system and service manager is responsible for controlling how services are started, stopped, and otherwise managed on a Linux system. Inside the lib system directory, there are several important subdirectories. Lib system. This directory contains unit files for services, socket units, and other resource types. Each unit file represents a service or resource that system can manage. These are typically provided by the package manager when installing a package that includes a service. Lib system user. This directory contains user-specific units, similar to the ones in the system directory, but designed to be started and stopped by individual users, rather than the system as a whole. The relationship between the files in these directories is that they both contribute to the overall configuration of the system manager. The lib system directory contains the unit files that define how to manage specific services and resources, while the other directories contain scripts and configuration files that affect how system itself operates. It's also worth noting that there are other locations where system looks for unit files, typical smiley face, etc. System. This is the place where administrators should put their own unit files. Files in this directory override those in lib system. Run system. This is a volatile runtime directory where units can be placed temporarily. They will be lost after a reboot. Remember that editing files in lib system is generally not advised, as these files are managed by the package system and your changes may be overwritten during package upgrades. If you need to modify a service file, it's better to copy it to etc. system and make your changes there.
Alright, so it was kind of like reading was trying to like read a emoji or whatever instead of just the text on what the text actually was. But I don't think I can change that at all. All right, so I'm satisfied enough to move on. Really kind of overcomplicating the question. I just want to get this cert as soon as I can, so I can move on to getting other certs and have a um, set of skills that are universally valuable in my field. And then from there, if I want to get a cloud cert, if I want to do whatever, then good. But I want to start with a foundation where, like now, if I'm looking for a job, I can pretty easily pick up a like Linux sysadmin role, something like that. That's really in line with what I'm looking for. Um, and where basically any company, multiple companies are looking for that. It's not like there's just you know. I put a lot of thought into this, and I think the LPIC makes sense as to why I didn't study for it yesterday. I don't know. That was not a good decision, but every other day is not bad when it comes to actually learning something. That's an effective way of doing it. But let's move on, keep focused, and try to close out this video. Stay on topic. We're already at the 30-minute mark. So, without looking at the answer, how can a default system target be verified in a systemd based system? So the answer to this is it's at a certain file. So now I forget exactly where it is. We did read that recently. So the answer is that okay, so it's a change. Yeah, so it's the so one thing you could do is uh I think you could do a systemd. Oh, here we go. Here we go. So this is the answer here. Systemctl get / default. So okay, and let's do it here. There we go, graphical.target. So that's a nice and easy one. It's just a memorization thing. So the symbolic link here will point to the unit file as defined in the target. The command system get default can also be used. That's the easy answer. This is the harder answer, which I was trying to determine here by looking through my system files. Um, let's let's do that. Let's go look at this symbolic link. So we're gonna do uh, now it's pointing to a unit. So it's pointing a unit is a file. So let's cat out that file. So one thing we might also be able to do is systemctl, and then status default.target. Since that is a unit, we can use this unit syntax. There we go, and we've got the unit status here. We can see it's graphical, so the equivalent of run level 5 if it were sysb. It is loaded, it is active. We can see it's at this. This is it there. So yeah, there's actually a third answer here. You can use this unit syntax and take an action against the unit to get the status of the unit, and then it shows you where the unit is actually located, all of that. So there's actually a hidden third answer to that question that I found. And yep, here's all the units. So it can be verified by now actually there's a fourth answer too, because you can cat out the actual unit file, and we can see that what it's set to in the settings of the file. So there's actually four answers to this. The first answer is system CTL get default. That's definitely the easiest, I would say, especially if you're automating, if you're coding and trying to get that through an API request or through whatever automated means. This is definitely the easiest. Then what you can do is do a system CTL get and then a action. The action you can do is to look at the status, and then you run that action against the unit file. There we go, and now you can see that it is graphical. And actually there's only three. The third one is you can actually look at the contents of that unit file, which is kind of what you're doing here, but no, it's completely different. Alright, so here's the contents of the unit file, and yep, I don't remember what the fourth one is. I don't think there is a fourth one. So these are the answer, but they're missing a hidden secret answer that we found. All right, last question: how can a system reboot be scheduled with the shutdown command be canceled? So this one, I think there's going to be hidden answers as well, because one of the things you can do is systemctl stop CRT systemctl stop. Is this the right? Yeah, systemctl okay, and now wait. Oh, okay. And now there should be something for like shutdown. Yeah, shutdown.target. So we can do systemctl status shutdown.target. There we go, and we can see it's inactive. If it were active, if it were, you know what? Let's try that. So we're gonna go shutdown, and then we're gonna do it after a few minutes. So time. So we're gonna say shutdown, and then we're gonna enter in a time. So we'll enter in 1,000. Let's enter in 10,000. I don't remember exactly how the time syntax works. We can do it. We can actually man on it. Man shutdown. So it should show it. Okay. So here's the syntax for the time. Let's set it in so plus m, we can set it to the number of minutes. We'll set it to 60 minutes so that we've got a good hour in case something goes wrong. Okay, and then the next part of the command, yep, so that's all we need to do is issue that there. So we're going to do shutdown in 60 minutes. Now we failed to set a wall message. So it looks like you have to set a wall message unless you do a dash no wall. But I'll just do a wall message. I'll say system is shutting down. And if you want to really be fun on the job and cruel, if there's a newbie on the job, you can create. You can do. Oh, we used to do this. I'm just gonna say we used to do this. So if there's a new guy who's for his first day on the job, you can say user J Smith. J Smith. Say critical error. Critical error made by user J Smith. System corrupted. Shutting down. So, yeah. Oh, it didn't work. Okay. Oh, you know what? It's probably... Yeah, so there we go. You needed sudo permissions. So, um, there we go. So shutdown. So here. So this is one of the answers. You can cancel it with shutdown -c. So let's do that. Okay, and that actually didn't work. We need to do sudo. There we go, and we don't need to do a wall message with that. So let's do the systemctl status, and then shutdown dot target. Okay, so I don't see anything there. Let's issue it again, and we'll do the same verification command. Okay, so we can see this is kind of not a good command to use. It's still there's no changes here. There's no green. There's nothing. Even though we do have a successful, we do have it scheduled there. So shutdown.c sudo shutdown/c is the easy answer. Let's try the other answer. So you know what? I don't think this will work. Let's go to ChatGPT and get some tutoring on this. I did the stop systemctl stop shutdown dot target command with the intention of canceling the scheduled shutdown. Would this command accomplish my intention? What if not? Then what was my error in understanding?
The command you executed, systemctl stop shutdown. Target would not cancel a scheduled shutdown. The reason is that shutdown. Target is a special system target that the system transitions into when it's going through the shutdown process. Stopping this target won't cancel a shutdown that has been scheduled with the shutdown command. If you want to cancel a shutdown that has been scheduled with the shutdown command, you should use the shutdown C command. This will cancel the scheduled shutdown. Here's how you can do it. This will cancel the scheduled shutdown. If you wanted to leave a broadcast message for all logged in users after canceling the shutdown, you could use. As an aside, systemctl stop less than service greater than is typically used to stop running system service. The systemctl stop shutdown. Target command doesn't make much sense in practical usage because shutdown. Target is not a regular service but a special system state.
Okay, so I didn't understand this correctly. What this command actually does is it would stop so shutdown.target is a special system D target that the system transitions into when it's going through the shutdown process. So this is only going to show up as uh, green here and active when the system is actually shutting down. So to stop it, it's not even started yet. That's what we did with this shutdown plus 60 command is we scheduled this target to be uh, active 60 minutes from now. So we can't stop it because it hasn't started yet. So that's the misunderstanding I had of that command. I believed that it was more for things like that it was the direct equivalent of a command like shutdown if you did systemctl start shutdown.target. It would, now in that case it actually might work because you'd be starting, that actually might work too. But let's ask the chat GPT. Could you issue the start command to shut down a system? Why or why not?
In system, shutdown. Target is a passive unit that represents the system state of being in the process of shutting down, but it doesn't actively cause a shutdown itself. Therefore, you generally cannot use systemctl start shutdown. Target to initiate a shutdown for your system. The normal way to initiate a shutdown using system is to use one of the following commands. Systemctl power off. This will initiate a full system shutdown, just like the traditional shutdown hnow command would. Systemctl reboot. This will initiate a full system reboot, like the traditional shutdown rnow command. So I'll shut down. Target is a valid system unit. It's not one that you can directly interact with using the systemctl start or systemctl stop commands in the same way that you would with regular service units. It's more of a marker that other units can use to express their dependencies, i.e. before equals shutdown. Target or after equals shutdown.
Okay, so again, I had a misunderstanding there. This is just the target to the shutdown process. If we look at what this file actually looks like, or what this unit actually looks like. Okay, I've got some problems here. I'll do a clear. Maybe that will help it. Okay, it's not helping it, so I'll reopen my connection. I typically just canceling a connection and opening a new one is really bad practice if you want to see if it will, because you might lose access to the system that way. A better way would be to open another terminal and create another connection, because it could be, because since it's TCP, once you have a connection to it, it's a stateful connection, so it's like you're gonna stay in there even if there's problems, but you might have trouble forming a new session. So what I just did there was really bad practice. I hope nobody else does that, and I'll be more careful to show good practices in the future. A better way would have been to start a new terminal, try to get in, even though I'm in already. There's plenty. I think there's 4 VTY sessions, so up to 4 users can get in there. And then if I can't access the system, now I'm already in, even though it's all jumbled and messed up, and I could try to troubleshoot. Okay, so I wanted to take a look at the contents of that file. So let me try to do that. and I forget. Oh, it would be shutdown.target. Okay, so here's the contents of that file. I forget why I wanted to look at that. But anyway, let I do need to still cancel my shutdown, I think, so I'm going to do a shutdown-c. There we go. It'd be nice if I could do like a show shutdown. There's probably a shutdown, a way to verify whether or not there's one scheduled. Or at least I hope there would be. I don't see it. But anyways, I did the SC, so I think it's all good. That's the answer to this final question. It's shutdown.c. Let's see what the official answer is. Official answer is shutdown-c. Alright, so in summary, this lesson covers the main utilities used as service managers. So there's three of them. There's sysv, there's upstart, and there's systemd. By Linux distributions, the sysv init technically is the whole thing, and then systemctl and upstart utilities each have their own approach to control system services and system states. The lesson goes through the following topics: what system services are and their role in the operating system. So they are system services are things that prepare your system to be used. They run programs at startup, do things like the other things they are used for is like rebooting the system. So the system services are basically the basic things your computer needs to do, and there's tools for doing them manually, but more importantly, system service managers are there so that those things happen automatically at boot up and you can get in and use that system. Let's see what the so we're going to say, what are system services and what is their role in an operating system? And just get a refresher from the AI on that.
System services, also known as daemons, are background processes that are typically launched during system boot and continue running until the system is shut down. They provide various functionalities necessary for the correct functioning of an operating system and the applications running on it. System services can be responsible for a wide variety of tasks depending on the specifics of the system and its configuration. Some common examples of system services include network services. These manage connections to and from the system over a network. This can include web servers like Apache or Nginx, email servers like Postfix, DNS servers, DHCP servers, and many others. Logging services. These collect and manage logs generated by the operating system and applications. The syslog service is a common example. Security services. These help protect the system from unauthorized access. This can include firewall services like IP tables or firewall-D, intrusion detection systems, and antivirus services. File and storage services. These manage access to storage devices and files. This can include the NFS service for network file sharing, SSHD for secure file transfer, or FSCK for file system checks and repairs. System and hardware-related services. These provide necessary functionality at the operating system level. Examples include UDEV for device management, cron for scheduling tasks, and system.init for system initialization and service management. Database services. These manage databases on the system, like MySQL or PostgreSQL. In the Linux world, these services are often managed by a system like system.init, which handles starting, stopping, and supervising these services. The actual services run are highly dependent on what the system is used for. The database server might run a very different set of services compared to a web server or a desktop system.
Okay, so my understanding was kind of close, but a little bit far off. System service managers. These are like systemd, sysv, system services themselves. These are the daemons on the systems, which are background processes that are typically launched during system boot. They continue running until the system is shut down. And they do things like set up network services, set up logging services, security services, file and storage, system and hardware, and database. All right, great answer from ChatGPT. It's really a revolution in personal learning, I think. So for me, it's worth the $20. Another thing I'd like to do quick is see what the other AIs say about that and if their answers are as useful. And then while those are generating, I'll go on to the next question. Concepts and basic usage of sysv, systemd, and upstart commands. So we saw that the sysv has all of these have. I'm not sure about upstart. I don't care about upstart, um, but you know, so what are the concepts and basic usage of for the commands? Okay, let's hear from the AI.
System B init, size init, upstart, and system are all different types of init systems. An init system is the first process that gets started when a Linux system boots up, and it's responsible for starting all other processes. 1. Size init. Size init, or system B initialization, is one of the oldest init systems. It was the default init system for many Linux distributions until it was replaced by systems like upstart and system. It uses numbered run levels to represent the system state. Common size init commands. Service less than name greater than start. Starts the name service. Service less than name greater than stop. Stops the name service. Service less than name greater than restart. Restarts the name service. Service less than name greater than status. Shows the current status of the name service. Init less than run level greater than. Changes the current run level, which can start or stop services. For example, init 0 halts the system, and init 6 reboots the system. 2. Upstart. Upstart is an event-based replacement for the traditional init system. The primary advantage of upstart is that it handles starting tasks and services during boot and stopping them during shutdown, and it supervises them while the system is running. Common upstart commands. Start less than job greater than. Start an upstart job. Stop less than job greater than. Stop an upstart job. Restart less than job greater than. Restart an upstart job. Status less than job greater than. Get the status of an upstart job. Initial list. Lists the known jobs and instances. 3. System. System is currently the most common init system and used on Linux systems. It's an extensive system and service manager for Linux operating systems designed to be backward compatible with size init. System brings faster boot times to Linux through parallelization. It starts services simultaneously instead of waiting for one to finish before starting the next. Common system commands. System CTL start less than name greater than. Service starts the name service. System CTL stop less than name greater than. Service stops the name service. System CTL restart less than name greater than. Service restarts the name.
Okay, so we can see I asked that other question to the other AIs, and it did better in ChatGPT 4, but the thing is, there was a lot of prior prompting, so I'll keep these open and I'll keep looking at them. I might even go ahead and bookmark this one. But I'd have to change the. All right, I just want to wrap up here. So we're gonna ask the final question: how to properly restart system service. Okay. So I'm gonna ask it, how can I? And this is really easy. It depends on which service manager you have. If you have system via init, then to stop, restart, stop, and restart system services, you'd use this service name of the unit of the service, and then start, stop, or restart. The system itself, you can do it in various ways. You can change the run level, so you can do a init 6 and change the run level to reboot, which will reboot the system. So that's an answer to that. With upstart, the syntax has changed. Instead of service, you just start with the action. So if you want to start a service, start, stop, restart, and then you put in the job there. The system itself, I'm not sure about that. It's just not showing here. It's probably something very simple like reboot or something. And then the syntax is different for systemd, the most recent one. You need to use this command, systemctl, which is kind of the equivalent of this service command here. And then now the action goes before instead of after, and then the service is a unit that shows that has this dot syntax instead of different syntax here. So yeah, next question.
Service less than service name greater than start stop service. Service less than service name greater than stop rest.
So starting and stopping and restarting system services, as well as rebooting the system themselves, are tasks usually performed via the command line interface, and the commands to use depend on the init system for your Linux distribution. Linux system is using. Okay, so we saw that here. It's just a different syntax depending on the service manager you're using for reboot. Yeah, so it's the same for all. Oh, I guess for this, you can still use this for system D. But yeah, okay, that's it for that. So the commands and procedures addressed were commands and files related to system V, like init there and there. The main system D command there, upstart commands. There we go. And then traditional power management commands like shutdown and the command wall. So that's it. All we got after that are the answers to the exercises, which we already went over. So that's it for this section. Thanks for watching and stay tuned. We're moving on to 102 from 101. So exciting things ahead.